Now this time, what we have here is what looks like a product of four things. 5x squared cosine 4x ln of x plus 2. However, you can really think of 5x squared as a single thing. Okay? It leads to the same exact answer. Okay? So let me first demonstrate to you what would happen if you consider these as product of four things. Okay? If you do that, then it will be 5 differentiated plus the next one is differentiated plus cosine 4x is differentiated plus ln of x plus 2 is differentiated. That's one by one. Now, what do you get if you differentiate 5? 0. Times something. I don't even know how to write this because 0 times anything is 0, right? Okay. What do you get if you differentiate the second thing? 2x. 2 times 5 is 10, so I can write down 10x cosine 4x ln of x plus 2. What do you get if you differentiate cosine 4x? Negative sign from the cosine, and 4 would come out because of the chain rule, right? So you end up with negative 4 multiplied to 5, which is minus 20. X squared sine 4x ln of x plus 2. And finally, what would you get for this? This one may need a little more thought. So first, x plus 2, treat that as the inside function. So this is like differentiating ln of x. ln of x differentiates to 1 over x. So what do? When you differentiate ln of x differentiates to 1 over what I covered, which was the covered thing was x plus 2. And then you have to multiply the derivative of the inside function, which is, what's the derivative of x plus 2? 1. So the final answer is, this one's gone, because it's 0 times. And times 1, you don't have to need it there. Times 1 is nothing. So this is the final answer. Okay. Now I want to point to you out that if you did not treat this as 4 different things, but just treat this as 5x squared, it's the same thing, right? Whether you distinguish 5 as another multiplied thing or not, it doesn't matter. If you did that, then it would still be the exact same answer. Why is that? That's because when you differentiate the very first thing, when you differentiate 5x squared, 5 is a number. It's a constant multiplied to x squared. So that just comes out naturally. 5 just comes out. And times x squared, if you differentiate x squared, that's 2x. So 5x squared just naturally differentiates to 10x. So you get the same exact answer. Yes?
For the second line where you differentiated 4x, cosine 4x, why does the negative 4 go to the very front instead of just in front of the cosine?
Oh, I mean, multiplication is commutative, right? So I can change the location it's multiplied. And I'm simplifying by just multiplying the negative 4 with 5 together. That makes things simpler, right? So I'm simplifying as well as I'm doing this. Yes, another question?
For the natural log, isn't it technically 1 over x times the derivative of x? Instead of just 1 over x?
Oh, So a lot of the textbooks have ln of x prime in this form. ln of a function u as 1 over u times u prime, or u prime over u. That's the format a lot of the textbooks have. But that's basically what I have here, along with the chain rule, because if you think about it, if we just simply have this rule, what is it? If you differentiate ln of u, u is a function of x, so it's a nested function. So you try to differentiate this as if you're differentiating log of x. It's the same thing, but because u is a nested function, you have to pull the u out and differentiate. Okay. So having this, if you just have this, and then you use the chain rule, it's the exact same thing.
So if it was like natural log of x squared plus 2 or something, it would be 1 over
X squared plus 2 and
times
2x multiplied. Yeah, that's how it would.
Okay.
So, and this all comes through practice. If you take this rule and solve lots of chain rule problems, you will eventually know this one. Okay? This will be more natural to you. Okay? But it's the same thing. It's equivalence. This, everything else I had that's x, that's why I put it like that. But in your textbook, you have this other version too. Do you have any other questions?